Hello, dear students. Hope you had a good time, and we all are aware about this pandemic situation. And as we are facing a lot of communication issues, then social distancing, many more issues with this disease called corona. And due to this, as we are aware that we are starting the e-learning from today, and let us see how the time allows us to come together again, and we will start the classroom learning. But before that, let us use the technology for e-learning, and I hope this is going to be a very wonderful experience as like classroom teaching also. So I would like to hear from you also after the lecture, and hope you will be very attentive this semester or this year also, because this is your last year and you will be stepping into your career after this academic year. So all of the subject what we study in all these 4 years, like that the final year subject also carry very important role in your engineering application career. So this is my first lecture, and this will be an introductory lecture for the subject. So let me introduce you the subject and how we will be taking the course over the period of time. So this is the introduction of dynamics of machinery. This is the one of the subject in your curriculum, and I will be teaching you the theory and practical of this subject. Okay, so let's go to next slide. So as per syllabus, you can refer the syllabus copy, and I will post this to your group also. The course code is 402043, and the teaching scheme is we'll be having 4 lectures per week, and currently we will try to see some practical based practical syllabus also we can see here, but let us see how it goes. But for theory at least we will have the 4 lectures per week, and then this is the subject of 5 credits. So 4 credits are for theory, and 1 credit is given for term mark. Okay, so theory is of 100 marks, so it carries 4 credits, and term mark is of 25 marks, so it has 1 credit, and there is oral head also, so it has 25 marks. So if you can see on the right side, theory exam is divided into, means 100 marks are divided into 2 parts. One is in-sem examination of 30 marks, and we all know this is the scheme of examination, that we appear for 30 marks in-sem paper, and which has the syllabus of 3 units, and then end-sem examination is there for 70 marks. So all of the weightages all you are aware, because till 3rd year you already have appeared these kind of examinations. So you will have the term mark of 25 marks, in which you will have to write the journal, including experiments as mentioned in syllabus, and there will be the oral of 25 marks. Okay, so this, you can see these 25 marks are very closely related to these 25 marks of oral examination. Okay, because this term work, basically 25 marks term work, is based on all of your 6 units. Okay, so your subject is very closely studied in term works, or closely studied in practical hours also, because in practicals you are applying the theory concepts we learn in theory classes. Okay, so term mark is of 25 marks. Now these 25 marks are not just 25 marks, but it is the practical abstract of the 100 marks theory. Okay, so here term work, what term work you are studying or you are writing into journal, that is a very serious job, or we can say it is a very important job. Okay, so mostly many students have the concept of neglecting the term work, or we can say taking it very casually, because term work, they take the journals and they copy it and again they write it, and once they write it, when they come for the oral examination, so oral examination, though it is of 25 marks, but the external, it is external evaluation, and external examiner completely is judging you on the basis of what you are answering, based on what term work you have performed in the semester. Okay, so most few students have the concept of copying and pasting, or we can say just copying the journals from your colleagues or friends. So that is not good practice, because that is going to reflect in oral examination also, and here is the chance you lose the score. Okay, so as you know, the market condition, okay, this market condition is highly, we can say weak, isn't it? It is very weak condition, or we can say the competition is very strong. And if competition is very strong, then when you are stepping for your interviews, then first step or first scrutiny or first gate pass to interview is nothing but your marks, isn't it? So before you appear for the interview, you need to qualify certain marks, and then only you are allowed for the interview, because for the company, for the one or two or few posts, there are thousands or hundreds of thousands of applications. So you need to be very careful about your career. Okay, so every subject of your engineering you should study very very sincerely, so that whatever the term work you are writing, that should be written on your perception about the subject and that particular concept of that particle. Okay, so after getting this, once you are very much sincerely writing this, then definitely your oral performance is also very good, and definitely you can score good. See, my point, or why I am very much thrusting on this term work part, because as I mentioned, this term work is based on whatever the theory you study in your 6 units. Okay, so when you are sincerely studying your 6 units, you can write your term work very knowledgeable way, and very intelligently you can write, okay, or smartly you can present your term work. Same thing can be reflected into oral marks, and as you have studied your all of the 6 units for the sake of term work writing, but that is useful for your in-sem and end-sem examinations also. So considering term work as the center, okay, and if you study all of your 6 units, so it helps to score very good in all of the 150 marks. Got it? So that was my point to explain. Okay, and that's why I am very much putting a thrust on this term work part, or this 25 marks, or we can say the journal. Okay, so take a writing journal very much sincerely, so that all of the 6 units you will study very good. Again, it will be reflected in oral examination, and same thing will be helpful in you getting very good marks in in-sem and end-sem examinations. So my point is, out of 150 marks, you will be scoring very good. Okay, if you take this term work 25 marks very seriously. Got it? So this is what is the the teaching scheme and practical scheme, and then examination scheme. Okay, so hope all of you understood this. Got it? So let's move to next slide. Now, course objectives means once we are learning something, learning and teaching both should be with some objective. We have some objectives to teach, and you people should also have some learning objective, means why you are doing this. Okay, so why you are doing this, the answer is, after successful completion of this course, okay, what you should be able to do. So after completion of the 6 units and practicals, means after completing the study of 150 marks, okay, you should be able to do the following points. Okay, so what is first is estimate natural frequency of single degree of freedom, undamped and damped free vibratory systems. Okay, so now this is important concept in vibrations. Okay, natural frequency. Okay, now this natural frequency is restricted to single degree of freedom. Okay, So all of we studied, or we are all know that the degrees of freedom, okay, in TOM. Okay, so you already studied in TOM, okay, theory of machines. Okay, degree of freedom is related to how many variables you require to describe the system. Okay, so if you require one, then it is single degree of freedom. Okay, and undamped and damped free vibrations. Okay, so you should be able to estimate, okay, the natural frequency of what? Free vibrations. Again, they are of two types, damped and undamped. Okay, and again it is third, that is a single degree of freedom. Okay, so as we will start the unit 1, okay, that time you will understand, okay, what is the degrees of freedom, then what is the damped and undamped, and what is the free types of the vibrations. Okay, so what is first thing after end of this particular 6 units, okay, end of the study, you should be able to estimate the natural frequency. Second thing you should be able to do is determine the response to forced vibrations. Okay, due to harmonic excitation, base excitation, and excitation due to unbalanced forces. Okay, so when the forces, various forces are acting on the system, okay, so you should be able to determine the response to forced vibrations. Okay, so in first objective you come to know about the free vibrations. Now these are the force vibrations. Okay, so in force vibrations we are applying the force. Okay, that is the difference between first objective and second objective. Okay, so in this way you should be able to determine the response in the force vibration, that is the second objective. Now third is estimate natural frequencies, mode shapes for 2 degree of freedom systems. Okay, so degrees of freedom all of we already know in TOM subject. Okay, and again it is free, longitudinal and torsional vibrations. Okay, so again these are the types of vibrations which we will come to know the unit, means we'll start the unit number 1. Right, so let's move to next slide. Now fourth objective is determine balancing techniques. Okay, so this is related to the unit number 4 where we'll study the balancing. Okay, so balancing is very much required, and as a mechanical engineer we come to know right from your first year you have studied in statics and dynamics, that is mechanics, the balance of the forces. Okay, so unbalance of the forces are causing various failures and various hazards in the dynamic systems or any automotive systems. Okay, so in this where this course objective will determine balancing techniques. Okay, so various balancing techniques means you will be able to evaluate the unbalanced forces. Okay, and that is in various types of the applications, like you can multi-cylinder inline and radial engines. Okay, so there are various rotating and reciprocating devices or applications in mechanical engineering. So in those, whatever is the unbalance, that you should be able to evaluate. Okay, so that is the fourth objective. Then last two objectives, okay, you can see they are related to measurement and control. Okay, so to control the vibrations, first you should be able to measure it. Okay, so that's why the fifth objective will be, you should be summarize vibration measuring instruments. So we'll study various vibration measuring instruments for industrial and real applications. Okay, and that is the measurement of the vibrations. So you should be able to summarize, means you should know what are the various instruments and how we can measure the vibrations, and what are the parameters of the vibrations which can predict the condition of the or level or intensity of the vibration in a particular application. Got it? So last objective is summarize noise reduction techniques for the industry and day-to-day life production. So here noise reduction is one of the objective that you should be able to summarize the technique. Okay, so how to reduce the noise. Got it? Because noise is basically it's a sound, and though it is a sound, but when sound becomes noise, means when it becomes irritating. Okay, so there are various health issues as well as stress issues. So whenever you are when you are studying in study room and when you are studying in any other place, so what is the difference? The difference is noise, isn't it? So why do you want to go to study room? Because there is a peaceful atmosphere. So noise level is very low, isn't it? Or we can say there is no noise, isn't it? So that the noise decides your state of mind, or we can say your concentration or your stress levels, isn't it? Also your performance. Okay, so noise is directly affecting your performance also. Okay, and not only human performance, that is just an example, but in industry the noise basically is the one of the cause, okay, or the one of the symbol, okay, and that is the signature. Okay, so the noise is coming, isn't it? So many of the industry or many of the applications, like even though if you're means when you're sitting in your home and your fan is making noise, then it is very disturbing to you, isn't it? So like you become panic and you suddenly get up and stop that particular fan, or you call the mechanic and you want to see what are the problems, isn't it? So then you just engineer that particular problem, and then you try to identify, you try to find out the solution for that, because the noise basically is very uh, it is distorting that particular device, the health of the device, its life of the device, isn't it? Or life of the that machine, isn't it? So as a mechanical engineer, we are more dealing with the machines, okay, and this noise should be reduced. Okay, so there are various techniques, and that you should be able to summarize them. You should know various techniques, measure the noise, what are the levels of the noise, and how to reduce it. Okay, and that is the objective. Okay, so hope all of you understood these 6 units, the 6 objectives. Okay, these are the objectives, and you should able to do after the course. Okay, so let's move to next slide. Similar to course objectives, there are course outcomes also. So after completion of this course, you should be able to apply the balancing techniques. As we discussed, the objectives and outcomes are similar. Okay, so you should be apply the balancing techniques for static and dynamic balancing of the multi-cylinder and inline and radial engines. Means you should be able to calculate the unbalanced forces, then estimate natural frequency, as mentioned above, also determine the response of the force vibration. Okay, and this is what is the course outcomes, these 3, and again there are another on the next slide. Let us move to next slide. Then fourth is estimation of the natural frequencies, mode shapes for 2 degree of freedom. Okay, that is different types of vibrations. Then fifth is describe the vibration measuring instruments, then explain the noise, last one its measurement and noise reduction techniques. Okay, these are the course outcomes. Okay, now let us see the syllabus. Okay, there will be 6 units. Okay, and as per university guidelines, we have some restricted number of hours, so we should be able to finish the syllabus in this particular number of hours. Now we should be thankful to the technology that once we record these lectures, or we can say whatever the presentations or e-learning material we have. Okay, even though 10 hours may not be sufficient, but you can refer this e-learning content moreover, and again we can schedule some online meetings, video meetings, and we can later elaborate more using this technology. Okay, that is the video conferencing. Okay, so first unit is single degree of freedom systems. Okay, and for the free vibrations. Okay, so before we go for this, again we'll start with the fundamentals of vibrations. Okay, so what will be the vibration, what are its the unit and the parameters, and how they are affecting the performance. Okay, so vibration, then again elements, what are the elements of the vibratory system, how to represent the SHM. Okay, so you can see in the slide, that is the SHM. So it's a simple harmonic motion. Okay, so what do you mean by SHM? Then what do you mean by degree of freedom? Okay, so then next is how the physical and mathematical model of the vibratory system, isn't it? So basically the vibratory system are to be model. Model means it is not the we can say, though it is both models are mentioned, physical model as well as mathematical model. Now mathematical model is nothing but you should be extract the mathematics of that particular system. Okay, so the way of representing the vibrations, okay, it has some mathematics that we'll study in the unit 1. Okay, so once we will be understanding how this modeling is done, or how mathematics of the vibration is represented, then again you should be able to relate the physical system, okay, and how it is, how the maths of that particular physical system is represented in the mathematical way. That is called as the mathematical modeling. Got it? So few examples are given, few applications. Okay, so bicycle, then motor bike, okay, that's the two-wheeler, and this the quarter car. Okay, so these are few applications which will be discussed, how the mathematical model is done in that. Okay, the next is the types of vibrations. Okay, so various types of vibrations you should know. Okay, then equivalent stiffness and damping, then formulation of differential equation of the motion. Okay, so when you will be evaluating the natural frequencies, okay, so to evaluate the natural frequency, or to you should apply various governing equations, and those are given by the scientist, that is Newton, D'Alembert, and there is one more, that is Rayleigh's. Okay, so Rayleigh's, D'Alembert and Newton, these people have given certain governing equations for this motion, and according to that governing equations, we should be able to find out the natural frequency. Okay, so again there are various types of the vibrations as mentioned in the next line. Okay, so damped vibrations, natural frequency of longitudinal, transverse and torsional vibratory systems. Okay, so these are all types of the vibrations which we'll come to know in the unit number 1. Okay, so the next part is the damp free vibrations. Okay, so different types of damping: viscous damping, over damping, critically damping, and under damping. So see, a damp, there are two concepts like damping and undamped. Okay, so damping means what? Damping is basically is the resistance. Okay, so hope you have experienced this, that is the resistance. Okay, so when you go for like when you are navigating using in a boat, okay, or when you are swimming, okay, so when you are moving your hands for propelling, so when you want to move forward, okay, so what happens, if you want to move faster, okay, when you are moving your hands very fast in water, isn't it? If you are a swimmer, you must know this. So when you are moving faster, then there is a more resistance from the water, isn't it? So this kind of resistance to the motion is offered, and this is one kind of damping. Okay, so this damping, okay, when you apply the damping, there is different types of dampings. Okay, so there is the viscous damping is there. Okay, air damping, coolant damping. There are various types of damping which we will study in coming lectures. Okay, and then according to that particular factor, damping factor, so this damping factor is some number, okay, that is based on the damping conditions. Okay, so this particular number decides whether the system is over damped, critically damped, or under damped. Okay, so that will decide how the system will behave, okay, if you vary the damping factors, isn't it? And that's why it is called as that means when you are applying the damper, okay, so it is called the damped vibrations. Okay, and when you are not applying the damper, then it is the free vibrations. Okay, so these three types of the conditions, okay, damping conditions we will study. Then there is a logarithmic decrement. Okay, so this is one of the part where when you get a vibrations, or when you see or observe the vibrations, then because of this resistance, okay, what will happen if you apply the resistance to the motion? Okay, so the motion is going to die, or we can say motion is one kind of energy, isn't it? So when you apply the resistance to this particular energy, isn't it? So to overcome this particular resistance, the energy is lost. Got it? So when the energy is lost over this particular resistance, then definitely the vibrations come down. Okay, and coming down of the vibrations is the decrement, isn't it? Decrement in the vibrations, and that is represented by the logarithmic decrement. Okay, so that is one part. Then there is a dry friction, then Coulomb damping. Okay, so these are also the types of the resistances. Okay, as I was explaining about the resistance to the motion. So there are the various ways you can resist this motion, isn't it? And these are the ways like viscous damping, then dry friction, then Coulomb damping, isn't it? So again, how they will be affecting and where are these cases coming? Okay, so that we'll study. Okay, and then there is a frequency and rate of decay of oscillations. Okay, so this will be studied. Okay, in this particular unit number 1. Got it? So let's move to next. Next unit is single degree of freedom systems, force vibrations. Okay, and it requires 8 hours. Previous unit needs that is unit 1 requires 10 hours. Okay, because it is quite quite more number of numericals are there in first unit. So second unit needs 8 hours. Okay, and in second 8 hours we have to finish this syllabus. Okay, you can see in the slide. Forced vibrations of longitudinal torsional system. Okay, so again these are the types of the vibrations, and these are the again another 2 types of the vibrations, longitudinal and torsional vibrations. Okay, so first thing is forced vibrations. So previous unit was free vibration. So in free vibration means you're freely suspending that particular system. Okay, you are allowing that particular system to vibrate at its own frequency or its own nature. Okay, and that's the free vibrations. But force vibrations mostly we come across in mechanical engineering. We come across the force vibrations. Why? Most of the systems, all of the systems, I am not saying most of systems, but all of the systems are connected with some prime mover. Okay, so if you see any mechanical engineering application, okay, it is some machine or it is some system to which some energy you are inputting and you are taking some output. So you are doing some work done. Okay, so to get the work done, what you need to put some energy in. Okay, so to put the energy in, what are the devices? Okay, so there are prime movers. Okay, and various types of prime movers. Okay, which are giving you the energy. Okay, so what is the energy? Basically energy in mechanical engineering basically is the motion. Okay, mostly the linear or rotary motion or reciprocatory motion we are giving the input, isn't it, to the system. Okay, so when you are giving the mechanical energy, okay, you are getting the work done with that particular machine or device. Got it? So this particular application of the mechanical motion with the help of prime mover, okay, it is called as the external source of vibration. Okay, or that is a force vibration, because you are applying some motion, some RPM you are giving with the help of motor, or some reciprocating action you are giving with the help of reciprocating mechanism, isn't it? And that causes this is one kind of external application, that is the external force application, and that becomes the force vibration example. Okay, so that is the force vibration, and next parts are the longitudinal and torsional vibrations. Okay, so longitudinal means what? Along the axis, and torsional means what? Rotary systems. Okay, so angular, torsional means angular. Okay, so whenever you have the rotating elements, like what are the rotating elements you studied in your TOM subject? There are pulleys, or there are the gears, isn't it? So there are many of such rotating mechanism where you come across this torsional kind of vibrations. Okay, and these are called as the torsional systems. Okay, so vibrations coming in rotary system are nothing but the torsional vibrations, and vibrations coming in the longitudinal systems are nothing but the longitudinal vibrations, isn't it? So we will study the frequency response to the harmonic excitation. Okay, so due to this rotating and reciprocating forces, okay, or base excitation. Okay, so there is another case where you have the base excitation. Okay, so means instead of we can say instead of the system, okay, or instead of the machine, okay, the base is vibrating, isn't it? Like suppose the machine measuring device, there is a measuring instrument. Okay, so measuring instrument is what? There is the system. Okay, but when you keep it on some base, okay, so base is vibrating. Okay, and because of that you are getting the vibrations, and that is one kind of base excitation problem. Okay, then the important part of the vibrations is magnification factor. Okay, so what do we mean by magnification factor? Okay, that we'll study here. Okay, so how much is the magnification factor? Okay, that will decide the intensity of vibration. Okay, so that again will come to know in this unit. Okay, and transmissibility is one more thing. Okay, so when like when you are uh, restricting or absorbing or isolating the vibrations, the transmissibility is one factor. Okay, that helps you to determine how much force or how much vibrations you can isolate or absorb, isn't it? So that is the force transmissibility and motion transmissibility. Okay, so that we'll study in this along with the quality factor. Okay, then there is a half power bandwidth method. Okay, to analyze this force transmission. Then there is a critical speed of the shaft having single rotor of a undamped system. Okay, so critical speed is another speed where shaft is vibrating erratically. Okay, so very dangerously it can vibrate. Okay, so what is that speed at which the shaft well, there is the whirling of the shaft phenomenon, and which is related to the speed. Okay, so as a mechanical engineer we should know the speeds, and the speeds are called as the critical speeds. Okay, so this critical speed analysis, okay, we will study in unit number 2. Okay, so these many things we have to cover in 8 hours. Again, I must say 8 hours are very less, but still as the guidelines, okay, by university, we will try to cover everything in 8 hours. But again I will say thanks to the digital technology, where we can again arrange few sessions where for the students who are not able to understand or they are lagging with some learning. Got it? So let's move to next to the unit 2, where in third unit we'll study 2 degrees of freedom system. Okay, now until the unit 2 we were studying the single degree of freedom system. Okay, so here we'll have one more degree of freedom, and after adding one more degree, okay, what happens to undamped vibrations, that we'll see. Again, this unit is restricted to 8 hours, and in this we'll study free vibration of spring coupled systems, longitudinal and torsional vibrations. Then there is a torsional equivalent shaft. Okay, so torsional equivalent shaft means in design subject you already studied some gearboxes, isn't it? So in gearboxes you must have seen there are the shafts in step. Okay, there are many steps in shaft. Okay, now when you are analyzing particular the vibrations in a torsional vibrations, then where like to avoid these tedious calculations, again we are moving, means the steps of the diameter we are converting into one diameter. Okay, and that process is called as the torsionally converting the system into torsional equivalent shaft. Okay, so that will give you certain dimensions of that particular shaft, and with that you can make the calculations of the vibrations. Okay, so then there is a natural frequency and mode shapes phenomenon. Okay, so this is another the very interesting phenomenon. There is a mode shape, and here with the mode shape you will be able to you will be able to predict the behavior of that particular shaft or a particular device or a particular system, so with the help of these mode shapes. Okay, so this is one more interesting part of this unit 3. Okay, where in university examination you face some numericals also. In this you need to solve the numericals. Okay, then there is a eigenvalues and eigenvectors. Okay, that also will study as the unit 3 starts. Again there is a combined motions. Okay, now combined motion means all of there are various mostly we come across 2 types of motions. Okay, one is the rectilinear, and rectilinear motion means what? It is along the line. Okay, and what's the another, that is the angular motion. Angular means it is around the center. Okay, so these are 2 types of the motion, but combined motions. Okay, like there is a rectilinear, means there is a the straight line motion also, as well as it is included with the angular motion also. Okay, now like when you are braking a vehicle, isn't it, when if you have a four-wheeler, if you observe the four-wheeler, in a speed and when it is moving, so when you brake that particular vehicle, so what happens, the vehicle is the moving in a line also, as well as it is it is a tilting also. Okay, so straight line motion as well as the angular motion. Okay, that is the rectilinear plus angular, means it is a combined motion. Okay, so we'll be studying that the analysis of that kind of system also. Okay, and last point is the geared system vibrations. Okay, so this is another application of the vibration, or the another system in mechanical engineering. It is the geared systems, and we will be studying some of the geared system problems, okay, related to vibration. Okay, so this is unit number 3. Now another unit is after your INSEM. Here this unit starts after your INSEM examination. Okay, so let's see how the INSEM examinations will be announced by the university, and hope so it will, and there will be some solution to this. But let it be irrespective of the INSEM examination. Okay, will be after the unit 3, this unit 4 will start. So here we will be studying the balancing. Okay, again it is restricted to 8 hours. Okay, so in this balancing, it's a very interesting again word, as I can say, all of us are very much observing our own balance, isn't it, or everything we need in balance, isn't it? Okay, so anything goes this or that way in more magnitude, then that will unbalance the system. Okay, may it be mechanical system or may it be anything. Okay, so the the nature itself balances the thing, isn't it? Just like that. So balancing is very important, if you want the systems to perform very good. Okay, so because of the unbalance there are various various problems, isn't it? Why to study this balancing? We are studying the balancing because of unbalance. Okay, so we want to removing the unbalance. Okay, that this particular act of balancing is nothing but the removal of the unbalance. Okay, so we will study unbalance basically, though the chapter name is balancing. Okay, so there are the static and dynamic balancing. Okay, so when in static conditions, how much is the unbalanced force, that we will be studying. Again we will be try to eradicate. Then there will be the dynamic balancing, means in dynamic state also there are very much unbalances. Okay, various types of forces and couples acting, and that will try to balance. Okay, then now this balancing is done in various applications. Like first is the rotating masses. Okay, now this rotating mass may be in single plane or it may be in several planes, isn't it? So all of you know the the inline cylinders where the pistons. Okay, so if you see the pistons of the inline engine, okay, so the crank, okay, crank of that particular inline engine that is rotating, and the masses are rotating in various planes, isn't it? So this is the example of the rotating masses in various planes. Okay, or that is the several planes. Okay, so single plane and more planes, that is several planes. Okay, then primary and secondary balancing of the reciprocal masses. There is another concept of the direct and reverse cranks. Okay, and primary and secondary unbalances. Okay, so this is one more concept that will be affecting. Okay, so there is a primary and secondary unbalance, and that is it is adding to primary force. Okay, primary unbalanced force. So that has to be counted, and for that purpose we will studying this case of the reciprocating machines. Okay, or reciprocating masses. Okay, then there is a balancing of the single cylinder engine, then multi-cylinder engine. Okay, then inline engines, then direct reverse cranks methods, then radial and V engines. Okay, so these are various applications in your syllabus, and which you will be able to calculate the unbalances. Okay, and you should be able to state the balancing, how much balance is required in what direction and how much in quantity, isn't it? So magnitude and the direction, okay, both way you will be able to predict the how much is the balancing force required, okay. And this particular balancing has one visit also, industrial visit, or we will go to some balancing unit, okay, where the automotive wheel balancing is done, okay. So there will be, you can practically can learn how they are balancing that, and how there is a machine alignment also, or wheel alignment, okay. So how the alignment is taking place, okay. So there is a very advanced techniques have come, and with the help of some sensors easily you can locate the unbalances, and you can predict how much balance force, or machine itself there is a software which can predict how much is the balance required, or how much balancing force is required for this, okay. So this is balancing unit, that is the unit number 4, okay. So let's move to next. So next, unit number 5 is measurement and control of the vibration, okay. So again we are restricted to 8 hours, and here in vibration measurement and control, okay. So before we are controlling the vibration, okay, we need to measure it, isn't it? So first is why to measure the vibrations, isn't it? Quality of the performance, basically it is determined, okay, if you reduce or if you have the least vibrations, isn't it? So you have to measure the quantity of the vibration, okay. And there are various instruments used, okay, for measuring the vibrations, but the need of the vibration measurement is vibration may influence the durability and reliability of the machinery systems, okay. So in mechanical engineering, whatever are the machinery we are dealing with, its durability and reliability is very much affected by these vibrations, okay. Now what happens, because of these vibrations it causes the problems, okay, such as there is damage or abnormal stopping and disaster, okay. So that's why vibration measurement is important. So there are various vibration measuring instruments, okay. Here basically we measure the frequency of vibration mostly, okay, amplitude and frequency of the vibration, okay. So basically one of the mostly used instrument is the accelerometer, okay. So there is another, that is impact so impact hammer basically is used along with the accelerometer, okay. So there is a hammer, and hammer impact is done, and we are observing the vibrations, or the accelerometer is basically taking that measurement, okay. So there is impact hammer, like vibration impact hammer, there is a vibration shaker, okay. So there is electrodynamic vibration, okay, or electrodynamic shaker, okay. So which is shaking, or we can say which is exciting the system, and or we can say externally it is giving the vibrations to the system, and we are observing the endurance, okay. So how the system is the durable against this vibration, okay. So there is a vibration shake, or we can say shakers, okay. Then there is a vibration analyzer, okay. This vibration analyzer, basically it is a vibration meter, and it measures the vibration, okay. So whatever is the, it is one kind of electronic device, okay, and it is able to process the vibration signals, okay. So whatever is the vibration parameters, okay, this device is able to process the voltage signal and display the vibration value such as acceleration and velocity, okay. So vibration, again, it is one kind of motion, and the motion is has the three basic components, that is the displacement, velocity and acceleration, okay. So if you are able to measure the displacement, then velocity and acceleration component of the motion, then basically you are able to measure the vibration, okay. So the device which measures this particular vibration is the vibration meter, or it's also called as the vibration analyzer. In condition monitoring, that is the vibration condition monitoring, okay, it is based on measuring values of specific parameters, okay, which are critical to failure, isn't it? So because of the if the part is wearing out, okay, means more wear is happened, and what happens, whatever is the tolerance, or whatever is the the fit between these particular mating components that goes wrong, and in a dynamic conditions it is making big noise, or basically the many vibrating parameters are giving erratic readings, isn't it? So most of the the popular the devices or the elements in machines, they are bearings, okay, or many components which are running out of the balance. Okay, so that in dynamic systems the parts are rotating and moving, and because of these rotations and movements, okay, there is always the wear out. Okay, so these are causing the vibrations, or we can say when they are going out of the running out of balance or running out of the tolerances, then they are making big noise and vibrations. Okay, so conditioning monitoring. Okay, so how condition monitoring is nothing but the health. Okay, what is the health of that particular machine? So it is totally assessed on the basis of this vibration measurement. Okay, so that is called the condition monitoring. So whatever is the reading, that is divided in some spectrum, and that spectrum is analyzed, and with that particular analysis we are able to identify the levels of the vibrations. Okay, and what is the human response to the vibration. Then next part of this unit is control. Okay, so there are various vibration control methods. Okay, so there are passive, active methods. Then there is a introduction to ER, that is electrorheological. Okay, so and MR, okay, that is magnetorheological. So ER and MR technology already you have studied in your some students have presented their this into seminars also, and you must be knowing this technology. Okay, so electrorheological and magnetorheological dampers. Okay, basically when you are controlling the vibrations, as I explained, vibration is one of the motion, and motion is one of the energy, isn't it? It's a kinetic energy, isn't it? So when you are damping it, damping is nothing but a resistance. So when you are offering the resistance to this motion, okay, so that resistance, the way of applying the resistance is nothing but one kind of controlling the vibration, isn't it? So if you see the shock absorber in your two-wheelers, isn't it? So how you are controlling the vibrations, isn't it? Whatever the shocks are coming from the road, isn't it? Because of the shock absorber only, the lot of the vibration energy is absorbed, isn't it? So whatever is the energy in that particular motion of the vibration, that is absorbed. Okay, so there are the active vibration controls. Okay, another means these were the passive, then this is the active control, active vibration control, then control of the excitation at source. Okay, so from where the excitations are generating, okay, applying the control over there, that is the control of excitation at source. Then control of natural frequency is again important, because all of we studied in our in our 12th. Okay, so phenomenon of natural frequency and why to control it, isn't it? So whenever the natural frequency is matching, okay, to the frequency of that particular system, then there is a resonance. Okay, so to avoid that resonant condition, okay, because resonant condition what will happen, the system will vibrate at its highest amplitude, or we can say infinite amplitude, and that is dangerous. Okay, so this that may cause like collapsing of the bridge, you must have heard, isn't it? So that is the problem with this. Okay, so that's why we need to measure, and also after measurement you need to control the vibrations for this purpose also. Then there are the vibration isolators, then dynamic vibration absorbers. Okay, then introduction to torsional dampers. Like rectilinear motion, there are the angular motions also, and in that there are the torsional vibrations. So how to restrict, how to arrest the torsional damping, how to arrest the torsional vibrations. So there are torsional dampers. Okay, so in this way we will be studying the control part also, so in unit number 5. Okay, so let's move to next. This is the last unit, introduction to noise, and it is restricted to only 6 hours. Okay, but it's very like another interesting phenomenon. Okay, here we'll study the fundamental of noise. Okay, now basically what is noise? Noise is again a sound, isn't it? So it is like how you differentiate it, like it is the sound only. Okay, so noise, how you differentiate the sound and noise, isn't it? So noise is basically unwanted sound considered unpleasant. Okay, so this is unpleasant thing. Okay, when there is a noise, isn't it? So when Like see now when we have the class, okay, so many students are they are they're discussing, okay, they are just chatting with the friends and some teacher is teaching. So what happens, many of the students are chatting, and then what happens, the noise level increases, and like sound level increases and it becomes a noise, the class becomes noisy, and then that becomes irritating, okay. So basically noise is unpleasant thing, okay. So it is disruptive, okay, for hearing, okay. So uh, differentiation, it is very difficult, like very difficult means it is scientifically it can differentiate it on the basis of the scale which we measure the noise, okay. But it is again perception, okay, I will say. Means like if you go for high decibel noise, okay, or high decibel sound like DJ, when you are you people, you students are very much enjoying your most of the events with the DJ, in gathering also you can see your Shiv Jayanti, you can see your you can see many of your wedding events. You are basically now, if it is a noise, then and if it is irritating, then why you people are dancing there, isn't it? So basically it's cheeky term, okay. So noise is a perception of the mind, isn't it? So how you perceive, okay, how is your mood, isn't it? So sometimes noise, higher levels of the sound you appreciate, and sometimes very low levels of the sound also is disturbing, isn't it? So like it's the bit like moody condition, okay. But noise is noise, isn't it? Means as if you measure like DJ sound, then it is also noise, okay. Noise is noise on the basis of scale, if you measure on the scale, okay. But again it is how you perceive it, isn't it? So is the noise. So there are decibel levels, okay. When you measure the sound, mostly the sound is measured in decibels, okay. So if you can take various cases, like when you are whispering something in the ears of your friend, then that decibel is something low. So what you normally speaking with your friends, it's into 60 dB, so sorry, 60 decibels. So it's a normal sound. Whispering is 30 decibel, isn't it? So motorcycle engine is 95. Above 70, above 70 decibel. If you continually hear this above 70 decibel sound, then it may damage your hearing also, okay. So this is the decibel which is differentiating sound levels or decibel levels. So loudness is basically above 120 decibel, okay. So these are the decibel levels. Then there is a white noise, then weighted sound pressure level, logarithmic addition, subtraction, averaging, sound intensity, okay. There are various noise measuring instruments also, which way there is one practical also on this, okay. So we'll measure some certain levels of the sounds in decibels, okay. Then there are sound fields, octave band, then reflection phenomenon, absorption phenomenon, transmission phenomenon, okay. So this is more related to when you're arresting this like when you're designing the acoustics basically, okay. So acoustics is you must be knowing the acoustics when you are designing certain community hall, okay. And when you are fitting it with some the speakers, okay, loudspeakers, and there is some the speaker, the person, okay. Now what happens due to wrong design of acoustics or sound reflection, absorption, transmission properties of that particular the hall, you are sometimes because of the echoes, because of that wrong design you get echoes, okay. And that becomes you cannot hear that particular speaker properly, isn't it? So this is related to noise, or this is related to sound reflection, absorption, transmission, okay. So that is also the sound pressure level, okay. Then noise control at the source, along the path, and the receiver, okay. Reverberation chamber, okay. So in the reverberation chamber we are basically this is used for acoustics, okay. So when you want to study the noise in the noise properties, then there is a reverberation chamber, okay, where you are performing the practical, or we can say you are performing the some noise test, okay. There is anechoic chamber also. Okay, so these are the sound analysis techniques. Okay, then there is a human exposure to noise and noise standards. Okay, so human exposure to noise, and there are the noise standards. Okay, which we refer. Okay, for analyzing the sound. Got it? So these are 6 units, and this is what is the syllabus, or this is what is the vibration, or this is what is the dynamics of machinery subject. Okay, so there are practicals, okay, related to this. Okay, and as you come in the campus, okay, we will perform the practical on that also, and we'll be filing one journal. Okay, so hope this presentation gives the idea of this particular theory. Okay, and 100 marks, as well as all of the practical and term marks are based on this only, isn't it? So if you learn these 6 units properly, so easily you will be able to get good marks in term mark, as well as in that is oral examination also. Okay, so I wish all the best to learning of this subject, and we'll be meeting tomorrow for the start of the first unit. Okay, so thank you for patient listening to me, and all the best.